and 71, flip binary tree to match preorder traversal. So the problem is that we are giving the root of a binary tree. So for example, this is the root of a binary tree. So the root is not 1, and it has a left child with not 2, and a right child with not 3. And for not 3, it has a child of 4 and 5. And let's check the right side. Yeah, so for the right side, we also have this not 1. And this is just a flip operation. So while we are flipping not 1, it means its left child gonna flip with its right child. As you can see, 3, 4, 5, it's gonna be here, and 2, it's gonna be at the right side. So this is the definition by the flip. And we also should know what is the preorder traversal. So it's gonna always traverse the root first, and then the left child, and then the right child. So this is gonna be the preorder traversal. Yeah. Now let's just continue. So flip the smallest number of nodes so that the preorder traversal of the tree matches voids. So we are also giving a voids array. So now let's just check that. So if it is not possible, so we're gonna return a -1. If it is possible, so we're gonna return an array. Yeah, so this is just the meaning of the problem. So we want to return the answer in any order. If it is impossible, we're gonna return a -1. So the order is that, let's just check the first example. We have the node 1 and 2, and the root node is 1, and the left child is 2. But we are also giving a voids array. So we're gonna continue the preorder traversal. So we're gonna first traverse node 1. Yeah, but for node 1, it is not equal to the first value inside the voids array because the value is 2. So is that possible to make it like 2, 1? Yeah, because the voids array, the preorder traversal is 2, 1. It can be this 2, 1, or it can be this 2, 1. There are two combinations, but it doesn't matter. But this is not possible, because while we are flipped the node 1, actually this node didn't flip. It flipped the left and right child. So if we flip, maybe this node 2 gonna be here, but it is still 1, 2 for the preorder traversal. But the voids array is 2, 1. This means it is not possible. Now let's just check the next example. This is 1, 2, 3. And for the voids array, it's going to be a root node 1, and the left child we can prepare a 3, and the right child we can prepare 2. So this is possible, because if we flip 2 and 3, it's going to be 3 and 2. It's going to be exactly the same. So this is possible. So this means we're going to flip node 1. So we're going to return an array. So inside the value is going to be 1. And let's just check the third example. So for 1, 2, 3 and 1, 2, 3, they are exactly the same. So we don't need to do any flip. We just need to return an empty array. Yeah. So this is just some examples. And we can also say that all the values in the tree are unique, and all the values in the voids are unique. So this means this information is really important. This actually helps us to solve the problem. If the value inside the tree, inside of the tree, for this example, inside of the tree, there is a duplicate. So definitely we cannot solve the problem. Yeah. Since the value is unique, so that means we can compare the values directly. But how can we compare that? Yeah, we can compare directly using the preorder traversal. First of all, we're gonna compare the first node, and we're gonna compare the first value. Because for preorder traversal, the first value inside the voids array, it must be the root node, and this is the root node. So this means this node can compare with the first value inside the voids array directly. Yeah. So if they are equal, so we're gonna continue to the next. So inside the voids array, we're gonna continue to check the next value. It is 3, and inside the tree, as it is a preorder traversal, we're gonna use this node 2. As 2 is not equal to 3, but we have the information, and we hope we can flip it. Yeah, if 2 is not equal to 3, we're gonna have a flip, because there's no duplicate value. Maybe this value is 2, there's duplicate, but we don't have that case. This makes the problem solvable. Yeah. So if 2 not equal to 3 here, we can make a flip. Now let's just make a flip. So after flip it, this gonna be 3 and this gonna be 2. Yeah. So if it is not equal after flip, we're gonna still compare this is 3 and this is 3. It is equal, it is okay. Now we're gonna compare this node 2. It is equal, it is okay. Now we have no node. We traversed all the node, and inside the void array there's no values. So that means this is possible. And we're gonna put the value 1 inside our result array. We just need to return this result array. Yeah. So this is the entire solution for the problem. Because the value is always unique, that means the problem is solvable. That we can use preorder traversal directly to solve the problem. Yeah. But for this problem, I think it is much easier to use a stack with the iteration. It's gonna be much easier. So the stack solution is that we're gonna prepare a stack for the preorder traversal of the tree. So we're gonna put the root node inside, and we're gonna check the stack, and we're gonna pop out the node. So this is just the preorder traversal by using the stack, which is the iterative way to traverse the tree. Yeah. Now we're gonna check if we're gonna check the right first. Yeah, because while we are using the stack, we need to pop the left first. That means we're gonna append the right first, append the left last, because we want to pop the left first. Yeah. So the stack gonna append not dot right. So if not dot left, so the stack gonna append not dot left. Yeah. So you should not only know how to write the preorder traversal in the recursive function, but you should also know how to write it in iterative function. But because for most of the cases, iterative way is much faster than the recursive way. Yeah. So this is the iterative way of preorder traversal for a binary tree. And now we just need to compare this void array. But before that, we're gonna prepare index. It's gonna be starting from 0. Since we pop out the node, we can compare the value directly. So if not dot value not equal to void with this I index, I mean the first value. So this one gonna compare with this one. So if it is equal, it is okay. But if it is not equal, it means it's not possible. We can return a -1 directly. Otherwise, we're gonna update the index I, and we're gonna check if we're gonna check from the left side. If not dot left exists, yeah. If the not dot left doesn't exist, it is okay. We're gonna directly compare the right side. Yeah, because if the left exists, we're gonna compare the values, right? Yeah. So if not dot left and not dot left dot value not equal to void with I, yeah, with my current value. Let me check. Yeah, if it is not equal, so for this example, 1 equal to 1 but 2 not equal to 3, what are we gonna do? We can swap it. Yeah, so we're gonna do a flip. So the not dot left and not dot right gonna equal to not dot right and not dot left. Yeah. So now we flip it. So what did we do? We flip it. So this gonna be not 3 and this gonna be not 2. Now we're gonna check if not dot right. So what is the not dot right? Yeah. So not dot right gonna become 2, right? So we're gonna put a 2 inside of the stack, not a 2. And then we're gonna put a 3 inside of the stack. Yeah. So this is inside the stack. Now we're gonna check while stack. So the not, we're gonna pop out this 3 first. Yeah. So we're gonna pop out this 3, and 3 is this value 3 equals to the void I. So we're gonna continue. Otherwise, we're gonna return -1. Yeah. So since it is equal, so I gonna plus equal to 1. So this gonna be the I, this is not I. Yeah, because before I equal to 1, now I equals to 2. Yeah. So if not dot left and not dot left dot value not equal, but currently it is equal, so it is okay for us. Yeah, because we've already flipped. Yeah, and then we're gonna put the swap the left and right and put it inside, but this is none because it is the leaf node, so it's gonna be none. We put none inside, it doesn't matter. Yeah. So now we're gonna continue. So while we continue, we're gonna check the stack, and we're gonna pop out the node, and this time the node gonna be 2. So the node dot value equal to the voice value, it is okay, and I gonna update it to 3, and up to here everything is okay, and I just go out of the while loop. So if I go out of the while loop, so everything's okay. I just need to return my final result, and I didn't define the result array. Let me define a result array, and which node I should put inside the result array. Actually it should be here. Yeah, because while I'm checking this node, while the node left exists and left not dot left value not equal to the value, I'm gonna swap it. Yeah, because after swap it, I can put the value inside, but this value gonna be my parent, so it's gonna be this node 1. So result gonna append the value, it's gonna be not dot value. Yeah, because currently definitely I'm sure the node 1 gonna be put inside before. So after I did the flip operation, I flip 2 and 3, but I can put 1 inside. But I cannot put 2 or 3 inside because I didn't compare that. Yeah. Now I can put the values inside, and finally I just need to return the result array. Yeah, now let me just run it and submit it. Yeah, definitely it works. As you can see, it's quite fast because this is the iteration. It's going to be much faster than the recursive way of solving the problem. And this is definitely a hard problem. The hard part is not about the preorder traversal. It is about while you are checking the voice array, you need to recognize this is going to be a preorder traversal, and then we need to find from where we need to check. So from the first, we're gonna check if the value not equal, we're gonna return -1. Otherwise, we're gonna update the index I because we want to go to the next. After comparing 1, we're gonna go to the next, 3 and 2 and next. So while there's nothing inside of the stack, we're gonna go out of the while loop and return the result. And here is also important. So while we are sure that we're gonna do a flip, so after this flip, definitely we can put this value node 1 inside. Yeah. So for some other cases, maybe let me use another color. So for some other cases, maybe we have a node 1, 2. It's gonna be like this. And now for our voice array, we have a value of maybe 1, 2, like this. Yeah. So we're going to compare 1 first, and then we're going to compare 2 directly. They are always equal, so we're going to just return this node 1. Yeah. But for this case, like 1, 3, 2, definitely we need a flip. I think that's all for it. Thank you for watching. See you next time.